Okay, let's look at page 215, number 10, section 3.5. Find the derivative of y with respect to x using implicit differentiation if x times e to the y is x minus y. So again, first step is always take derivatives of both sides. Since I'm wanting derivative of y with respect to x, x is the independent variable, so I take derivatives of both sides with respect to x. Okay, even if you use prime notation, please at least write this much with Leibniz notation. That'll really help you later on. Now I have a product, because y is, remember, implicitly a function of x. So I've got a product. Nothing's constant here, except for the base e of the exponential function. But I've got the product of x and e to the y, so I need product rule. So that's first times derivative of the second plus second times the derivative of the first. Now again, I'm afraid if you just write this, x e to the y prime plus e to the y x prime, you might forget to use chain rule. When that prime here means the derivative with respect to x. So I really think this notation, this Leibniz notation, is better. Okay, the derivative of a difference is the difference of the derivatives. Okay, so on the right-hand side, this is just the derivative with respect to x of x, that's 1. And this is just derivative of y with respect to x. You can go on and write this 1 minus dy dx rather than writing this derivative with respect to x of x minus derivative with respect to x of y. That was an intermediate step most of you can do in your head. Okay, let's finish the left-hand side. Derivative with respect to x of e to the y. The e to a variable is the outside function. The y is the inside function. So the derivative of the outside function is e to the y. The derivative of an exponential is itself. But then I've got to multiply by the derivative of y with respect to x. If you go back and review for a second, if I want derivative with respect to x of e to the 3x, that's just what? The derivative of the outside, derivative of the exponential is itself, but I got to multiply by the derivative of the exponent. So that's just going to be 3e to the 3x. Okay. Derivative of x with respect to x is just 1. So I have x e to the y times derivative of y with respect to x plus e to the y equal 1 minus derivative of y with respect to x. Again, the rest is just algebra. I want to solve this equation for dy dx, so I bring the terms involving dy dx to the left. So I add dy dx to both sides. And I bring the terms not involving dy dx to the right. So I subtract e to the y from both sides. I did 2 steps in one there. Subtracted dy dx, rather added dy dx to both sides, subtracted e to the y from both sides. Now, dy dx is written twice, but I want it written just once, so factor it out. Here's what I'm left with. Again, dy dx times x e to the y is just x e to the y dy dx. Dy dx times 1 is dy dx. When you factor, you can always check by multiplying. Okay, now I have dy dx times this expression, x e to the y plus 1. So to undo multiplication, I divide. So divide both sides by x e to the y plus 1. There's no cancellation here I can do because there's nothing I can factor out of the top or the bottom. So here's my answer. Again, if you've got a question, refer to the virtual office hours and send us an email. Okay. Find the equation of the line tangent to the graph of x squared plus y squared equal 2x squared plus 2y squared minus x, all quantity squared at the point 0, 1/2. This is number 29, section 3.5. So if I want the equation of a tangent line, I need to find the derivative. But I'm given an equation involving x and y. So I've got to use implicit differentiation. So my first step is to find derivative of y with respect to x using implicit differentiation. So please try this one, and then we'll let you check your work before going on.